Okay, everybody. So what we're going to be looking at today is going to be working with sequences, but in MATLAB or Octave instead of on paper in theory. Okay, so let's just remind ourselves of what a sequence is. So remember that a sequence is just a list of numbers, right? Like what you have. Oops, that's not what I want. Aha. Um, just like this one, 2, -2, 4, -4, 6, -6, that kind of thing. Okay. And we know that you can also calculate terms from the sequence if you have a formula for doing that. So like this sequence right here is an equals 1 over n squared. And I believe we did that, right? So let me open up that as well. Here we go. Oh, wow, mess. But we did it, right? So we were calculating 5 terms of this sequence. So the sequence here is 1 over n squared. And so we put a 1 in and get 1, a 2 in and get a quarter, 1/9, 1/16, 1/25, right? And then that's a formula, or not a formula. The formula 1 over n squared gives us this sequence that you see right here, right? And it just goes on forever. So how would you code that in MATLAB? Okay, so there's a few different ways to do it depending on how much of like MATLAB's fancy stuff you want to use. But let's try to do this. So I'm gonna create a new script here. So I'm gonna go um, File, New Script. So I'm in a new script. I'm doing this in Octave. Of course, works just fine in MATLAB as well. And so let's say I want to make this sequence an equals 1 over n squared. Well, I just need a way to get this formula in here to produce these numbers. And however I do that is fine. So, well, first of all, how many terms do we want? Do we just want 5? I can do 5. Let's do 5. Actually, let's do more. Let's do like 6 or something, or 10. So I'm just gonna have like this capital N at the top of my script, and that's gonna be how many terms to compute for that. Make a comment. Will compute in terms from the sequence. Because of course we know that sequence just goes on forever, right? That's what the dot 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 is. So I'll just put a number here that will be my how many I want to do. Okay. Now, one easy way to do this is to just use a for loop. So if I want to compute n equals 10 of these, I can just say for, you can use I, you can use n. I'll use lowercase n. For n equals 1 to capital N. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? And then in this for loop, what I'm going to do is I just need to basically just put this formula here. So what I want to do is I want to put these numbers in a vector so I could look at them later. I don't just want to calculate one of them at a time, because I could do that, right? Like if I just put this formula in 1 over n squared, so like a equals 1 over n squared, like that. Actually, let's put the semicolon off. This will calculate the right numbers, right? So if I save this, what do I want to save it as? How about, what are these called? Sequences. Sequence. Script. Okay. And then if I come here and I run the script, ds sequence script, no .m when you run the script, it will calculate these numbers. Not is exact form though. It'll only calculate them as decimals that you can see here. But if you look at the first one, it's 1. It should be a 1. The next one should be a quarter. It's a quarter. 1/9. That's 1/9. You can just check that real quick, right? If you're confused, 1/9. The next one should be 1/16. This is 1/16, and so on, right? 1/25 is right there. Type 1/25, you can see that that's right. So there you go. So these are definitely the right numbers from this sequence here. But like I said, we don't just want to just throw them up on the screen. We want to store them in a vector. So the way you might want to do that is just say, well, how about instead of just calculating them, how about we do this? AN equals 1 over n squared. I could put like a semicolon on the end, so I don't have to see it. Then what we'll be doing is we'll be storing them in a vector called A, instead of just a variable called A that has one thing in it. So now if you run it, you get nothing, right? But if you check what A is right here, and it has the numbers that we want in it, okay? Now, something I have to caution you about for dealing with these things is in this script right here, like let's say I don't want to calculate 10 anymore. Let's say I only want to calculate 5. So I change that number to 5, right? We'll compute in terms from the sequence. I change that to a 5. So now this n will be a 5, and we'll only calculate 5 of them, right? So I save it, come down here, I'm gonna run my script again, and I look at A, and nothing changed, right? We still have 10 columns. Now the reason we do that is because, look, like right now, this variable A with 10 things in it, right, 1 by 10, already exists. So when this script runs, you can change how many numbers you calculate. We're only going to calculate 5 new numbers. But what about 6, 7, 8, 9, 10? We didn't delete them. They're still there. Okay, so when you do something like this, you should be careful to like basically clear out that A vector before you start, just to be on the safe side. So you can just type like clear A or something like that. That'll work. Now you don't have to do that, but it will save you from this issue where you thought you were calculating 5 things and you actually calculate 10. And the worst thing is, so see, now we got 5. But the reason you want to at least think of that or know about this issue is because think about the case where I do something like this. So let me get rid of the clear A. Let's go back to 10. So like, let's say I do this and I run my script. I'll run it by clicking the button this time. Say file run. So I go to here, A, and you see the numbers, right? 1.25. There they are. Last one 0.01, right? Because that's like 1 over 10 squared. 1, 2, 3, 4, 6. We have these numbers here, and the reason I was reading them out loud, some of them, is just we want to recognize them. I guess we can scroll up and look at them. So the problem is this, like what if I make 2 changes? What if I say, okay, now we're going to calculate 5 things. And then after you calculate 5 things, right, so you click run again, you come down here, you look at the vector, everything's the same, so you're not worried. And then you say, oh wait, no, actually this is not the sequence that I wanted. I didn't want 1 over n squared. I wanted, 5 over 2n squared. That's the one that I really wanted. This is the sequence that I wanted. And so I save it and I run it. And then we look at A. I've got a problem. Because here's what happened. We just calculated 5, right? 5 terms from the sequence. So these first 5 terms, columns 1 through 5, they come from this formula. The second 5, 6 through 10, those numbers are the same numbers from before because we did not recalculate them. So when you make multiple changes like that without clearing out your variable, what we've got is now a weird case where half of A contains the 5 numbers we were trying to calculate, and the second half of the A vector contains garbage, right? This is left over from when we were calculating a different sequence. Not good to have that there. So that's why I would advocate like clearing your variables. And if you're not worried about losing anything, you can just actually just kind of start your script with clear, and clear will clear everything. If you want to only clear specific variables, you can just say clear A. Don't do this. Don't do something like this. This is wrong, like ABC with commas, because remember, like commas actually are like go to the next line in MATLAB. So if you want to clear like ABC, you have to do clear A, B, C like that. So like if I wanted to clear A and N, I would do it this way. All right, so let's change this back. Save, run. A. Okay, and you'll notice, right, A is now a 1/5 vector because we cleared out the A. We did not need to clear out the N for anything because we were going to recalculate it right here. But this is just how you clear multiple variables at once out of memory. All right, so that's one way to do it. You just in a for loop, right? But MATLAB is good at processing sequences and vectors and things. So another way to do it, I'll just calculate the same sequence here, but you could actually calculate it in one line. You could just do something like this. Like, let's put it in B. B equals, and what you can do is, here's the formula, right? Like the formula is 1 over n squared. That's the formula, but I don't have an n. What do we want from n? Well, if I want to calculate like 5 numbers, right? The first one comes from A1. The second one is, or sorry, the fifth one is 5, right? 1 through 5 is what I'm trying to plug in. So in order to replace this n here with 1 through 5, you can just replace it in parentheses with 1:5. Just like you do for a for loop, you can do that right here. That will calculate 5 of these all at once. But if you do that, you have to remember when we talked about like element by element arithmetic, this is a vector, right? Like if I go to the command window and I type 1:5, it's literally these numbers in a vector. So if you put a vector here, the vector, you want to square it. Well, you can't square a vector. You need each element squared. So you have to change the exponent to a dot exponent. And you can't divide by a vector, so you have to change the division to dot division, like that. But that's plugging in 1 through 5 to where the n is. And if you save that, save. I run the script. We have A is right there. B is the exact same vector. Now, it is a little bit hard to look at this form right here. So like if I was actually doing this for myself, this is not quite how I would have typed it in. I would have done it in 2 lines at least. I would have done something like this. I would have done like n equals 1 to 5, or you could even do 1 to capital N if we want to keep using this. And then down here, I would have just put the formula in like this. So this way, it looks basically the way we did it up here. The only difference is n is now a vector, and so I need the dot the dot division and the dot caret in order to get element by element arithmetic. But it's nicer to look at in 2 lines like this. And of course, if I run it, there we go. That's n because I didn't put a semicolon on it. What's B? B is the correct numbers. Semicolon. So that's another way to do it. So this computes sequence A n. This is just down here, another way to do it. different way. Okay. So there's different ways to do this, but at some point, what's going to happen is you're going to need to calculate um, recursively defined sequences. So I'm scrolling down to recursively defined sequences. So a recursively defined sequence like this one, remember how it goes. It goes, you get, you have a formula like this bn here that actually refers to other b's, right? Like bn needs bn minus 1, okay? And so you can't calculate them with this second method if you're calculating a recursively defined sequence. You pretty much have to do it in a for loop. I shouldn't say you have to. There's always like weird tricks that you could try. Okay. So if you want to try to calculate a sequence, like maybe we'll do this one. So what do I want to do? I'm going to come up here and this one bn, I'm going to change it to like yn so I can use b right now. Okay, save here, and I'll clear out b just to make sure that it gets recalculated every time. Okay, save. So how would you do a recursively defined sequence? Well, basically to do a recursively defined sequence like this b up here, you just calculate it the same way we did the for loop. That's all you have to do. So like, let's try this. So we're going to try to calculate computes 5 terms. We'll do 6 terms of this sequence. I'll just say a recursive sequence. And this is not actually like super hard or anything. Like I said, you pretty much just do what we did here in this for loop. So I could do like for, we'll say n equals, we're going to change this, but like 1 to 6 if I was doing 6 terms. And then what's the formula here? So the formula is this. So up here, right, we had an and then the formula. Well, we should down here have bn and then the formula for b, right? So we go bn equals the formula. And the formula is right here, 2 minus bn minus 1. So we type that right here, 2 minus b parentheses in minus 1. Make sure you get the n minus 1 in parentheses there, right? It's subscripted here, so in parentheses over here. And there you go. Now this is not going to run. Right? If I run this, we'll get an error b undefined, right? So here it says, why is it undefined? Well, that's because the first time through the for loop, n is 1. So it goes b1 equals 2 minus bn minus 1. So it tried to access b0. But there's no b0. There's no b0. It doesn't exist. So it fails on calculating the first b because it refers to b0, but there is no b0. So you can't just have start at b1 calculated from b0. First of all, there is no b0, right? So what you actually have to do is just actually not just pay attention to this bit right here, the second bit. You have to pay attention to the first part over here as well, right? This part was important too. So it says the sequence is b1 equals 3. And then you do this. So you start out with the b1 equals 3. So you just say b1 equals 3. And then you can do this. The only thing you have to be careful of is if b1 is 3, then we don't need this to start at 1 anymore. We need it to start at 2 because we already calculated b1. Does that make sense? So we calculate b1 here, and then we want this to start at 2. because we already have 1. So you put in the, having a brain fart here, but like the initial state, and then this is what they call the recurrence relation. And you just type them both out like this, and just make sure your loop starts at the right place. Now I've hard coded this to go to 6. I could also put a capital N here and then come up here and change the capital N to 6. It doesn't matter. And this should work. So if I run this, it just runs now. And let's look at B. It should be this. It should just go 3, -1, 3, -1, 3, -1. Does it? Yeah, 3, -1, 3, -1, 3, -1. Perfect. So we calculated it. Now in your homework, you have to calculate Fibonacci numbers. Okay. Now again, I mentioned this in the notes. It's right here, but I'll mention it again. So the Fibonacci numbers in your book start with F0 equals 0, like I wrote right here, and F1 equals 1. But we are going to start with F1 equals 1 and F2 equals 1. And it turns out that the series or sequence is exactly the same sequence. It's just whether you have above this F1 equals 1, it could say F0 equals 0. But I don't have that here. The reason I don't have that here is because it's kind of a pain in MATLAB to do it that way, because there's no 0 index in MATLAB. So you can never do this. Like you can never access B0, right? Because it'll tell you that the subscript must be 1 to whatever. In C and Java and so on, your arrays start at subscript 0, but in MATLAB they start at 1. And so if I can avoid trying to access a 0, I will, because what I would have to do to store the sequence with F0 equals 0, F1 equals 1, what you would have to do is F0 equals 0 would actually be in the first element, right? So F0 would be in spot 1, F1 would be in spot 2, F2 would be in spot 3. Everything would be off by 1, and it would be a pain. So I'm using it the way that I highlighted it. So let's calculate the Fibonacci sequence. Calculates the Fibonacci sequence. Okay. And, we'll stick with 6 like we have here. No, let's go 8, because we got 8 right here. All right, so how would we do it? Well, we just copy the same form that we used up here. So the way you get started is whichever values you're told specifically. So like F1 equals 1, F2 equals 1, you just type those. You just go F1 equals 1, F2 equals 1. Got to get those right. If you don't, then everything else will be wrong. And then for the others, we're going to calculate them in a for loop just like we did here. So we'll just go for n equals 2 to capital N again. And how do you calculate Fibonacci numbers? So the way you calculate Fibonacci numbers, the formula is right here. But remember how you do it. It's basically just you add up 2 to get the next one. So 1 and 1 is 2. And then 1 and 2 is 3. And 2 and 3 is 5. And 3 and 5 is 8. And 5 and 8 is 13. And 8 and 13 is 21. Okay, so you just calculate them in order. So go to your for loop. I've already made a mistake, haven't I? Right? We have F1, we have F2. So where should this start? Think about it, right? We already calculated 1 and 2, so we shouldn't start at 2. We should start at 3. And then we just put in our formula. What's the formula for Fibonacci? Right here. Fn equals Fn minus 1 plus Fn minus 2. So Fn equals Fn minus 1 plus Fn minus 2. So the first time through here, n is going to be 3. So this is going to be F3. This is going to be F2. And this is going to be F1. And F2 and F1 exist because we typed them right here. So everything will work out. So that's a recursively defined sequence. Let's run the script. No errors. What's F? 1, 1, 2, 3, 5, 8, 13, 21. There it is. 1, 1, 2, 3, 5, 8, 13, 21. And if you want to change this and you want to calculate more Fibonacci numbers, that's really easy. We just change this to, you know, put 20 there. Save. Run. F. So there are your 20 Fibonacci numbers. Right? So there you go. You know, there's other ways you can do it. You can do it in while loop. So like if I want to do something different, you can do it this way. Let's see. Like I could say while, let's say we want to calculate Fibonacci numbers up to a certain size. So let's just say while f end is less than 100,000. Oh, let me also, how do I want to do this? I don't want to call it F. Let's call it G. Everything's a G. I don't want to overwrite my other ones. So like if you want to calculate Fibonacci numbers up to a certain size, you could do it this way. You do have to be careful here. So look at what I'm trying to do. So I've got, actually, let's not do 100,000. It's hard to see. Let's do 1,000. So while G end is less than or equal to 1,000. So what G end is it's always the last element of G. So for example, like look at the F vector. What's the last thing in F? 6765, right? So if I type this F end, I get 6765. Now, if I knew it was 20, I could have said F20. Oops, F20 was 6765. But if you don't know what number it is, you don't know that it's the 20th element, but you still need the end, you can just call it end and it will find the end. So I'm cheating here, not cheating, but since I don't know how many things G has in it, and I don't feel like keeping track, I can just look at the end this way with G end. So what this is going to do is it's going to keep calculating Fibonacci numbers until we pass 1,000. Okay. In fact, I'm going to take this. No, I'm not going to take that. Yeah, I am. I'm going to take the semicolon off this so we can actually look at what this one does. So let's see what G does. So let's run the script. Error. Bounds. What? Oh, there's no end. Oh, okay. So there's no end, right? I didn't have a loop counter. So how do I want to do that? Well, you can get kind of sneaky. One way is to just put in the counter, right? Like I could just say, like, n equals 3. That's the next one. And then after I do this, I can just do n equals n plus 1, right? So if you do this, then you're going to have a loop counter keeping track of where you are in the sequence. And then what I wanted to show you was the way this works. So 1, 1, 2, 1, 1, 2, 3, 1, 1, 2, 3, 5, right? Every time through, it adds another one on the end. So it adds the 8, adds a 13, adds a 21, adds a 34, adds a 55, adds an 89. But let me scroll. I'm using arrow keys to scroll down to the bottom here. One more. So this is where it stops. So it calculated Fibonacci numbers up to here, 1597, right? And that's where it stopped because that's where this condition failed, right? Gn less than 1,000 failed. So if you use a while loop structure like this, it works fine, but you don't get numbers less than 1,000. And the reason I'm explaining this is because it's relevant to your homework, right? You have to calculate Fibonacci numbers less than 4 million, I think. Well, you're not going to get them all less than 4 million because the one on the end is actually bigger than what you asked for. We asked for them less than 1,000, but we got one past that, and then it stopped. So if you want to deal with that, there's a bunch of different ways you can fix it. One thing I want to do right now is actually get rid of this extra in here. We don't need it. So if I want to calculate this and I don't want to use in, what you can do is actually change these indices to refer to where the end is. So like, for example, I want to calculate, so I'm going to erase the line up here in a minute. But if we have like 5 things in the sequence at some point, you want to calculate the next one, right? If there's 5, then we'd be calculating the 6th. So that would be one past the end. So G end is the end of the sequence. So the next one would be end plus 1. So that's actually one past the end of the sequence. And then what you need to add up for the Fibonacci sequence is, well, to calculate a certain one, you need to add up the one before it and then the one before that. So if this is the one we're calculating, end plus 1, the last one we calculated was G end. And the one that we calculated right before it is G end minus 1, like that. And so if you calculate it this way, then you don't need a variable for the index because you're just referring to the end. So what we're saying is if you take the last one that we calculated and the one before that, so you add up the last 2, and then we're going to store it in end plus 1, which is one after the end of the sequence. So that's a way to do it. I'll show you another way in a minute. So let me, yeah, we got semicolons on it now, so we don't see it. So let's just run the script. Don't see it. G, and there you go. It's doing the same thing. Now, if you think this is confusing, you don't like the ends, there's another way you could do it. There's another way to do it. I guess I'll call it H this time. H, 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 H. Actually, we're not going to do it that way. H. So you can still use the end to check whether or not you should stop. But then what you were going to do is, in order to calculate this, what you could do is you could say, well, the new H vector is, and we're going to actually write out the vector. So what we want in the H vector is the old H vector. And then what we want to do is onto the end of H, we want to add a new term. And the new term is H end plus H end minus 1. You can put a comma there if you want. So the idea here is that we're making a vector and we're putting this after the old H vector. So that's another way to do it. If I run this, same thing should work. It should work. It runs. Here's H, same as G. Now, how does that work? Let me just be clear here. So like, let's say I take X equals 1, 5, 7. That's an 8, but that's okay, right? One way to extend the X vector is this. If you do X equals X, you just get the same vector back, right? But if you do X equals X, and then you put another number here, 77. That's a way to just stick a 77 on the end of X. And that's what we're doing here. So you got the square braces, and then we put the original H, and then this is the one we're adding on the end, which is we're adding up the two previous. The two on the end of H get added up and are included as a new element of H. Okay, so that's another way to do it. So you can use a while loop, you can use a while loop, you can use a for loop. For loop's probably the easiest way to do it. Do a for loop if you know how many you're calculating, right? Like if I know I'm trying to calculate 20, then use a for loop. If you don't know how many you're calculating, that's why you would need a while loop. Also, just a comment about how to fix this issue where like you have like G equals up to 1597, and actually you only wanted less than 1,000, so you didn't want the 1597 on it, right? Well, the easiest way to deal with that, honestly, is not to try to do something complicated in the loop. If you want to calculate them less than 1,000, just do it exactly the way I did this or this, and then when you're done, just erase it. You know you went one past the end, you stopped one late, so just do this. You just say G end, that's where the 1597 will be, and to erase it, you just say equals, and it's not 0, don't do 0. Empty square brackets is nothing. Like that's like that actually removes whatever was in GN. So if you do that, and we can copy it down here for H, same thing. What happens is if I look at G now, you see it stops at the 987. We still calculated up to the 1597, and then I erase the 1597. So that just erases the 1597. Same thing there. And that's just kind of a cheating way to do it, right? It's too easy. All right. So let's look at one last thing here, which is convergence. So convergence here, when you're convergence means like leveling out here, right? So if I look at my notes, oh, I didn't actually, did I? Where? Convergence, yeah. So when you have sequences that converge, right, they level out at a specific line, right? Not like this, that's infinity, not like this, that's negative infinity. They do this, right? They level out at a line, and that line is the limit. And so if you're trying to test if a sequence converges, then what you would do is you just want to look at the sequence in a plot, basically in MATLAB, and you can just visually verify whether or not it converges or not. And so I think I have this script here. I don't like it. I'm going to do a new one. Let's make a new script. File, new script. So how would we do this? So if you want to check if a sequence converges, you would need to plot it, basically. So let me come up with a convergent sequence. Here's one we did, right? Limit of a sequence, and it was 2. So let's plot this sequence. So let's do like, capital N equals 20. We're going to plot 20. Okay. And then we're going to do it in a for loop. So this is not a recursive sequence. So this one I'm going to plot normal, but you can plot a recursive sequence same way. So I'm going to go 1 to n. And actually, let me clear everything, because what if I use the same variables as my previous script? So I'm going to clear them all out, and let's calculate sequence. Let's calculate this one in particular. A n equals 2 plus 5 over n plus sine N over N, N. Right? So actually calculating 20 things in the sequence is really easy. So I'm going to say like convergence plot, no underscore. All right. So if I run this right now, we're not going to really see much. Oops. Oh. N equals 1 to N. Right? We didn't see anything. But if you look at A, called A, right? Yeah. Then what you get here is the terms of the sequence, right? And whatever you put here is how many you'll calculate, right? So if I put a 50 there, I get 50 down here. Oh, 50. Okay. And one thing you can do is you can just, if you're trying to determine if a sequence converges, is you can just calculate a whole bunch of them, right? Like n equals 200. Do that. Let's look at the vector. Scroll all the way down, arrow keys. And if you look at the end, where does it look like these numbers are going to, right? 2.02, 2.02, 2.0207, 2.0206, right? It looks like they are coming down to 2, right? And we knew that the limit was supposed to be 2, but you can actually see the numbers get closer to 2. What we want to see, though, is I want to see it on a plot here. So here's what I would do. So I've calculated my sequence, and then I want to plot them. Now, if you just do this, plot A, that will actually work okay. It's going to take a minute for this plot to load, but we'll just wait for it. Take your time, not in a hurry or anything. But what you're going to see when this plot does load is it's going to be jagged line. And that's not what we want. Let me just move it over here, actually. Can't move it. Load faster. Man. 4.5 gigahertz. Can't load a plot. Well, anyway. Oh, there it is. Okay. Yeah, so you see what we were talking about, right? So it's jagged, and it goes from 1 up to 200. When you plot just one single variable, you don't have x's and y's. It assumes that you just have y values. And so that's why it plotted them on the y-axis, and the x-axis just is 1, 2, 3, 4, which is what we want. So that's a good plot. But what's not good about the plot is we don't usually plot them that way, right? We plot sequences as dots. So we want dots. So the way I'm going to come here, I need to change this plot to be dots. How do I do it? Well, you just need to change the style here, basically. So if you Google this, it's easy to do. So let's do like MATLAB plot style. I know what they're called markers. If I know that, I can type that in. Line specification here. And you can get this like solid lines, dashed lines, dotted lines, circle lines, plus signs, asterisk, point, cross, square, diamond, hexagram. I'm going to do square. Should be fast this time, though. So what it did was it plotted a bunch of squares there. Now 200 is probably more than we want. Like maybe let's go 50. No, that's 500. 50. Maybe this is good. Octave's plots are not as nice looking as MATLAB, though. Okay. If you want a different symbol, you just pick a symbol. X's are good. Lots of stuff's good. Circle. Circle is an O. All right, we'll do circles. Okay, and there's ways to fill it in and make them bigger and change the color and all that stuff. Like I think if I do like this, like RO, I should be able to get red circles. There they are. Okay. Now the thing is that maybe is not doing a great job of showing you that whether or not this is converging. So when you make a plot, you want to, add an axis where the axis is going to be the limits on the y-axis and stuff. So like, where'd my plot go? I erased it. Let me save it. So I want to basically zoom in and I can see these approaching a particular value, but I can't tell what value they're approaching. So maybe I just want to plot this. You see the graph starts at 2 to 3. Maybe I just want to look at it from like 1 to 3 or something like that. So like for X's, I can go 1 to, I guess, N. And for Y, I want to go, let's go 0 to N. And for Y, let's go minimum of 1, maximum of 3. And I need to parentheses to close that, save, run. So it's the same graph, but now we're looking at it at a different, different scale on the y-axis here, 1 to 3, because that's what I put here. So it goes xmin, xmax, ymin, ymax for the axis command. And you can see it looks like it's going to 2, but we don't know for sure. Put 500. Okay, so now look at this sequence. Where is it going? Looks like it's going to 2, right? So when you see a sequence level out the way this one did, they're all overlapping, so they're hard to see. But when you see a sequence level out at a particular value, that means it's converging. So if you look at the plot of a sequence, it's easy to tell if it's converging or not. If it goes flat out to the right, that's convergent. Okay. So there you go. And then the rest is just kind of, you want to make this pretty, right? Put grid on there. Legend. That was just my test sequence that I plotted from the notes. What else do I want? Do I want a title? Convergent sequence. Save. Run. Okay. So, I mean, there you go, right? Print. Sequence plot 1. .png. I'll do a PNG, which is just going to give me a PNG of the default size. So it's here, but also what happened? Oh, oops. I don't know why I did. Those should have been lowercase. I don't know why I uppercased them. Yeah. Run. Okay. Yeah. Now I got a legend and I got a title. And also save my plot. Open. So there's my amazing looking plot. I mean, not really, but there you go. So you can change the marker styles and everything, and I would recommend that you do this. Notice that I looked at, I typed MATLAB line styles or whatever I typed in, and I'm using Octave, but I just read the documentation for MATLAB, right? They're so close that you can do that. I'm not sure 100% of these are in there, but you can check most of them are in Octave. Main thing was not use a line for a sequence. Use a marker, one of these guys, right? Whichever one, you can go through and you can play with them. X, BX, blue X's. Is that better? I don't know. Okay, so that's going to be how you plot a sequence. Now you can plot any kind of sequence. You can plot a recursive sequence. It's just up here where I did a for loop, you would need, whatever we did for recursive sequence, right? Like if I wanted to plot this sequence here, the one that went 3, -1, 3, -1, you can just do everything that you do for a recursive sequence. Put it right here. There's a recursive sequence. And then plotting B. And let's only do 15 of these because that's all we're going to need. And so anyway, right, this right here is a recursive sequence. But notice all I did was I just copy pasted it and changed the plot to B. And I have a bad axes now though. Let me look at my notes. What was that sequence? That sequence was this one. It goes 3, -1. So we should probably go from like -2 up to 5 or something for the y-axis. Okay. Yeah, that's hard to see. Let's go. All right. So hopefully you can see this okay. If not, what happened, so this was that sequence that went 3, -1, 3, -1. So it's up here at 3, -1, 3, -1, 3, -1, 3, -1, 3, -1. So this is not leveling out at a particular number, right? It's bouncing around. And so this is a non-convergent sequence or a divergent sequence. So you saw on the previous one, when it leveled out, that is a convergent sequence. Also, you can plot multiple sequences at once if you want. Like I can just do this right here. I have these B's, but sequence. Now the problem is with plotting them, you kind of, if you want to plot the A's and the B's, you can't just do like A, B like that, because it's going to assume that the A's are your X values and the B's are your Y values. So you would have to actually tell it to plot on the X-axis 1 to N, and then A. And then on the X-axis 1 to N, and then B. So if you're plotting multiple sequences, you kind of need to put in X and Y's, X's and Y's. And then blue circles, and let's do red circles. So X values, Y values, how to plot it. X values, Y values, how to plot it. That should be a lowercase. Run. And so the blues are one of my sequences, and then the reds are the other. The reason I just put them on the same graph here was to point out the idea is that a convergent sequence levels out, like this one does. A non-convergent sequence does not level out. So this one's bouncing around, but it could also head off to infinity or whatever. I didn't fix my legend, but you get the idea, right? Okay. So I think that's it for now. I'll do another lecture about this, maybe. Work on the homework. Homework is not going to be due Friday. Like the homework says, due Friday. I'm changing that to next week. All right, so that's it for now. I will talk to you guys later. Close your eyes.